Okay, so we've got loads of information, but the first thing we're asked to do is to complete a diagram. Okay, so I'm going to refer back to this information in a second, but let's draw this out and complete the forces diagram as it asks us to do. So in my diagram, it's already showed me a vertical force of 25,000 G coming up. So I'm going to work with the vertical forces first. So I want to consider the weights. Now all the trucks are 25 tons. This one's also going to be 25,000 as a mass, because you work in kilograms times G for the gravitation or force. And the engine was 80 tons, so I get 80,000 times gravity. Now this whole set of trucks and things aren't flying downwards. So remember that we have got our normal reactions. Now how I would usually do it, I just call them N1, N2 and N3. Now technically you could call these the same ones because they are going to be the same. They're both going to be 25,000 times gravity. You could also, because you may note that it isn't moving up or down, it's just moving horizontally, you could have specifically shown that we have a matching normal reaction to the weight being pulled down. So if you'd rather have called it by the actual values, they'd have got U marks as well. Okay, you would not get the marks if you just put N for all of these, because you have to show that at least the engine one is a different value of N. Okay, so that's our vertical forces. They're all balanced out because it's not moving up or down. So now we're going to have a look at our horizontal forces. So if we start with the engine, I've got my driving force, it's called D, coming here. Now if I look, the resistant force on the engine, it says it was 2,000. So I've got 2,000 coming back there. However, we must remember between all of these here, we cannot forget that we're going to have some tension in the couplings between them. Okay, now you can show those on one line, or you can draw separate arrows. So if you think about it, the tension here is going to be pulling this engine back, because these two trucks here being attached are going to slow it down. If there wasn't a driving force, it would probably come to a stop. Okay, however, that same tension, because it's in the same piece of rope, is going to be pulling this first truck forward. Okay, so I'm going to call that T1, and they are the same. If I come back onto truck A here, however, truck B is pulling truck A back. So I'll call this T2, so it'll be a different tension or thrust, depending on what happens, but we'll call it T for either of those, and that's going to go forward. Okay, but let's not rush. I've also missed the resistances. So it said that the trucks had resistant forces of 600 newtons. So let's just draw those on as well. Okay, and we should end up with something like that. I've not put my N for newtons on all of them, so I'll just make it like that. And there is part A. Okay, so part B says calculate the value of D. So let's have a look into that. So a reminder, whenever we're thinking of forces, we're going to specifically tell the examiner what we're considering and which direction. So when we have these ones here, we can consider the system as a whole, or we can consider each individual bits. Now if we consider the system as a whole, that cancels out these tensions, so that's quite a helpful thing. So I'm first of all going to consider the whole system. I'm just going to make a note that my forces I'm considering are going to be horizontally to the right. That's going to be my positive direction. Okay, so I remind you that we now use F equals ma. So if I look at the horizontal forces of the whole system, I've got D is going forwards. And now I'm not going to write T1 here because I've got minus T1 and positive T1. So I'm just going to write these resistances. So I've got minus 2,000, minus 600, and minus 600 again. Okay, and that's equal to the mass times the whole. Now, because we've considered the whole system, I need to consider the mass of the whole system. So 80,000, add 25,000, add 25,000 is the mass, times by the acceleration. Now, I always used to draw this on, if you remember when we did this. Okay, I forgot because I'm going between cameras and stuff. But the acceleration is 0.1, it says it in the question. So I'm going to times that by 0.1. So let's just neaten this up. So I've got D minus 3,200 is equal to 130,000 times 0.1. And then we can rearrange. And I believe I get D is equal to 16,200. Just there. Okay, next part. Okay, so the last part says calculate tension in the coupling between the engine and truck A is larger, or it says that it's larger than the coupling between the trucks. Determine how much larger. Okay, so I need to find both the tensions and then say how much bigger it is. Let's have a look at doing that. Okay, so if I take this forces diagram that I did at the start, what I'm going to do is I'm going to consider truck B, and that will allow me to find the tension T2. And then I'm going to use that and take truck A, and I'm going to use that to find tension T1. I could use the engine, could use anything you want, but that's just how I'm going to do it personally. It's up to you which way you do it, as long as you find the two ones, and then I just find the difference between. So, let's write this down formally. So if I consider truck B, and again, I'm going to move the forces horizontally to the right. Okay, so we're always doing F equals ma here, because I've got some acceleration. The system isn't going at constant velocity, it's moving with acceleration of 0.1. So if I look at truck B, I've got T2 in the positive, take away 600 is going backwards, and that will equal, the mass is 25,000 times acceleration, which is 0.1. So reduce and rearranging, and I get 2,500 add 600 is 3,100 newtons there. Okay, so that's my T2. I'm now going to consider truck A. I could have considered the engine, it's up to you. Again, I'm just going to clarify that I'm going in that positive direction again. And if we do F equals ma, I've got T1 now is positive. Take away T2, take away 600. Make sure that you don't just forget the resistance, just because we've got other stuff going on. And that equals, well, truck A is 25 tons or 25,000 kilograms. And the acceleration is still 0.1. So T1, take away, well, I just found out that was 3,100. Take away 600 is, that's going to be 2,500. So rearrange it, and I get that T1 is equal to 6,200. Okay, however, let's just go back to the question. The question says, determine how much larger, and it's talking about the coupling between the engine and truck A compared to the truck. So I need to answer that question by finding the difference. Okay, so I'll write out a sentence, the difference, 6,200, take away 3,100, so 3,100 newtons bigger. Now, when we did mechanics questions, sometimes we like to write a nice neat sentence, so I would, maybe if I had time and I wasn't rushing an exam, then write the coupling between truck A and the engine is 3,100 newtons larger than the truck's coupling. I've run out of paper, but you see what I mean. Okay, and that's it for the whole question. Alright, I'll just get the whole piece of paper in so you can take a screenshot if you need it. That there, and I will try and send that through. Oh, it's not a rubbish end bit. Alright, but there you go. Let me know if you have any questions.